All right, today we are going to be moving on to day 2 for simplifying our rational expressions. Mr. Janshigo took you guys through the notes yesterday, and hopefully that went pretty well and that you guys kind of have a decent understanding for how we can factor and simplify expressions. Remember, again, what makes something rational is that we have a variable in the denominator. So any rational expression means you have a variable in the denominator. So for example, 2x over 3x squared is a rational expression because the variable is in the denominator. If we were to take away clicker's stuck here. Sorry. If we were to take away the x squared in the denominator and it was just 2x over 3, that would not be rational. That would be what we would consider a line. It's linear, if you remember that from first semester. But to be a rational expression, you have to have a variable in the denominator. So keep in mind, greatest common factor. Maybe we have 5x minus 10. If we're looking for a greatest common factor, what do both of those terms have in common? They both have a 5. So we factored out an x, after we factor out the 5, we're left with x and then negative 2. Guess and check. Maybe we have x squared plus 8x minus, what would work here? Negative, let's go negative 48. We can think about some factors of 48. One of those is 12 and 4. X plus 12. X minus 4. 12 minus 4 is positive 8. 12 times negative 4 is negative 48. That's our guess and check. Problems that have two terms, subtraction, and the terms are perfect squares. We can use difference of squares. Square root of 25 is 5. Square root of 9 is 3. We are going to add once, and we are going to subtract once. And there we have the difference of squares. So those are just some of our factoring methods to keep in mind here as we move on to simplifying our rational expressions. Today we are going to be dividing rational expressions, and we're going to do it just like we divided fractions first semester. So let's take a look at the first example here. You'll see the division sign there, and the thing about rational expressions is that they look just like fractions. So if I ask you guys to do 2 over 3 divided by 4 over 5, remember when we divide fractions, it's really multiplication by the reciprocal. So it's 2/3 times 5/4, which gives us 10 over 12. We always simplify. That becomes 5 over 6. When we divide, it's the same as multiplying by the reciprocal, where we flip the numerator and denominator. The same is going to apply for dividing rationals here. My advice to you would be to factor first. So when we look at the denominator of the first expression, we have 4x squared minus 100. There's nothing to do in the numerator. We just have that constant of 3. So we're going to leave the 3 in the numerator. We always look for a greatest common factor first. I'm going to pull out a 4. That's going to leave us with x squared minus 25. On the other side, for the time being, we're going to leave the 6 in the numerator. We're going to factor the denominator. We have 3 terms. There's not a greatest common factor. This is going to be where we use guess and check. That factors to x minus 5 and x plus 2. Negative 5 times 2, there's negative 10. Negative 5 and positive 2 makes negative 3. So I factored the denominator. We can go a little bit further with our first rational expression. We have the 4 that we pulled out as the greatest common factor. X squared minus 25, that's difference of squares. We have 2 perfect squares, 1 and 25. The 1 in front of the x squared tells us that the first term in the parentheses will be x and x. The square root of 25 is positive 5. We're going to add 5 once. We're going to subtract 5 once. So I've split up x squared minus 25 into x plus 5 and x minus 5. Now this is the part where we can turn our problem to multiplication. X minus 5 and x plus 2 go in the numerator. 6 goes in the denominator. We're going to take the reciprocal here. So now we look at factors that we can eliminate. We have an x minus 5 in the numerator. We have an x minus 5 in the denominator. I don't have anything else in the numerator that would cancel out with anything in the denominator. So it stays 3 parentheses x plus 2 in the denominator. The 4 and the 6 are both coefficients, or both factors that are just integers. 4 times 6 is 24. Remember, we're multiplying. All of that goes together. And then the x plus 5 stays in parentheses. So that last step after we've simplified or canceled out our factors would be to take a look and see if we have any fractions that we can simplify. 3 over 24. 3 is a common factor of both 3 and 24. So we can simplify 3 over 24 to 1/8. So we end up with an 8 in the denominator, and the x plus 5 stays. And there is your first example for today. All right, let's take a look at our final example for today. In the first expression, we have x to the 4th over x minus 4. There's nothing to factor there. I do have an x in the numerator and an x in the denominator, but we can't cancel out an x when there's subtraction. It only works through multiplication. So we're going to leave everything the way it is. X to the 4th over x minus 4 divided by 5x to the 3rd. It's only a single term. It's a monomial. There's nothing to factor there. We look at the denominator, and we have 10x minus 40. You'll notice we have a greatest common factor of 10. We've simplified and factored as far as we could. This now turns to multiplication. So we have x to the 4th over x minus 4. We're dividing by a rational expression. That means we're going to take the reciprocal. Our problem changes to multiplication. We have 10 times x minus 4 over 5x to the 3rd. Let's see what we can cancel. We can start eliminating things from the numerator and denominator now that we have multiplication. X minus 4 cancels out with x minus 4. In the numerator, we're left with 10 times x to the 4th. In the denominator, we're just left with 5x to the 3rd. Remember, the final thing we do once we've condensed the rational expression and simplified the best we can is we look at our coefficients. 10 over 5. We know that simplifies to 2 over 1. We have x to the 4th over x to the 3rd. Remember, x to the 4th in the numerator looks like x times x times x times x. X times itself 3 times in the denominator. Those are our exponent rules from earlier on this semester. 4 minus 3. Whoops, sorry. I factor or cancel out 3 x's from the numerator, 3 from the denominator. What's 4 minus 3? 4 minus 3 is 1. Well, look at that. We have 1 x left over. We started with 4 in the numerator. Started with 3 in the denominator. Where do the leftover ones go in the numerator? 2x over 1, we can simply just write as 2x. So very similar to what you guys did yesterday with simplifying the expression, canceling out the factors across multiplication. The biggest thing today is when you see that division sign, we know that we are multiplying by the reciprocal. So multiply by the reciprocal when dividing rational expressions. All right, good luck on your practice today. Mr. Janchigo and I will answer questions when we get back. If you finish your assignment early today, make sure you finish your practice from day 1. Have a great weekend.